Hi, this is Barrett Givens, and in this video, we are going to define the concept of a topology. We've already talked about what a basis is for a set, and so we're going to define a topology in terms of a basis. You should know that this is not typically the way topologies are defined in most topology textbooks and in probably many topology classes as well. But I like to do it this way because I think it's just a little bit more intuitive to start that way, and that we will eventually get to the point where the definition from other topology books is going to line up, like by a theorem, with our definition of a topology. So in the end, it'll all turn out to be the same. But I just I just like this way of doing it. Okay. And topology is an interesting area of math in that there's often more than one way to define something. And so there might be like, three different ways of defining the closure of a set, which is a concept we're going to learn about later. And then whatever way your book or your professor uses to define the closure, then the other two ways end up being like theorems that they're equivalent. Okay. There's many like equivalent ways to say things. All right. So at any rate, we're going to define topology in terms of a basis. So suppose you have a set X with a basis B. We're going to form this new collection of sets called T. T is any sets that can be written as unions of basic open sets. So a set is in T if and only if it can be written as a union of basic open sets, along with the empty set. So the empty set will also be in T. And we'll say that this collection is called a topology on X. And we also say that B is a basis for T, that B generates T, or T is generated by B. And then finally, we call the sets in T the open sets. Okay. Um, all right. And so maybe the first example that I want to talk about, example, let's let X be the set of all real numbers, and we'll let script B be the set of all open intervals A comma B, such that A less than B are real numbers. So in this example, the open intervals are basic open sets. And then the topology, which is the open sets, will be anything that can be written as a union of these basic open intervals. So the idea is that the basic open sets are like the building blocks. They're like the Legos. And then the sets in T, the open sets, are the ones that can be built out of the basic open sets. So some examples of open sets that we might look at. Some examples of open sets. Well, first of all, the empty set is open because it specifically says so in the definition. It specifically says that the empty set is always considered an open set. Okay. Any basic open set. So like if I look at the open interval from 0 to 1, that's open because it's a basic open set. But also, let's say I want to look at something like 0, 1, union 5, 10. That's written as a union of two basic open sets. Or what if I want to look at something like 0, 1, union 0, 2, union 0, 3, union 0, 4, union. So the number of sets that you take the union of could be an infinite number. So this simplifies to be 0, infinity. So the interval from 0 to infinity is open. It's not a basic open set, but it is because you can't write it as just a single open interval with numbers at each part. I mean, it is written as an open interval, but there's an infinity there. That's not a number. Or something like, I mean, you could sort of imagine like negative infinity comma 8, because you could just write that as 7 to 8, union 6 to 8, union 5 to 8, union 4 to 8, and so on and so on and so on. Okay. So the typical open sets look like either intervals or unions of intervals or half open intervals. Oh, what about I could do something like the union for n in the integers of n comma n plus 2. What does that look like? So I'm thinking about all possible intervals of the form n comma n plus 2, where n is an integer, and I'm going to union those all up. So that looks like dot, 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 uh, negative 2 comma 0, union negative 1 comma 1, union 0 comma 2, union 1 comma 3, union dot 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 in the other direction. What do I get when I union up all of these intervals? I claim that I get the whole number line. I've covered everything. Okay, so these are some examples of typical open sets in this particular topology. And I did this topology as the first one for a reason. So this topology is extremely important. This is called the standard topology on the reals. Okay, so actually, anytime in the future that I say X is the set of all real numbers, and I don't specifically mention the topology, then you should assume it's this one. This is the topology where the basic open sets are open intervals, and the other open sets are just either open intervals or unions of open intervals, or the empty set. All right, thank you for listening.